Namaskar, welcome back. So, last discussion where we stopped was related to the base level change. Let's see further what exactly it will that the landforms will change and the how the rivers will incise. Okay, so this is a typical uh, channel profile which has been shown here. Okay, so this is your longitudinal profile. But what we see here is that another line is there which shows a sort of an irregular shape. Okay. Now, these are the areas which will eventually get eroded. Okay. And wherever there is a depression, that areas will be having the deposition. Okay. So, erosion and deposition will take place with respect to your channel profile and the channel, as I told, that it will try to bring itself in equilibrium. Okay. So, longitudinal profile and concept of grade, equilibrium of the stream flow, then we have topographic slope here, and we have climate control. Of course, the stream flow is there, that is discharge and velocity. Q is your discharge and V is the velocity here, and then resistance of rocks. Okay. So, usually we also look at the what will be the roughness in the stream bed, and then sediment load. And then sediment load can be resulted because of multiple reasons. If you are having loose material available, and loose material is very much available in Himalayas because it is very fragile and very young mountain chains. So, you have the sediment which are available are very like easy for the stream to carry in their bed load. Okay. So, this is again the same part, that is stream profile, but let us look at what is what are the further implications of this. Okay. So, mostly in the headward side or the upstream, you will have steeper profiles, and towards the mouth you will have almost flat profiles. Okay. So, longitudinal profiles and the concept of grade change in the base level. Okay. That is the quest for equilibrium. So, whenever there is a change, the river will uh, behave accordingly, or river will try to, or this river profile will try to bring itself in equilibrium. Okay. So, graded stream profiles, the quest for the variable balance. Okay. So, it will try to bring itself in balance. Okay. So, long example, we take a very matured stream, it will show a very classical profile as we have seen in the previous slides. Okay, with respect to the base level. Now, suppose there is a change in the base level because of tectonics. So, as we have seen in the previous one of the slide where we started discussing about the base level. So, if there is a damming because of natural damming, because of the landslide or because of your uh, lava slide and all that, that will change the environment in the upstream as well as downstream, and that remains same as if you are having the man-made dams and all that. Okay. So, this is uh, the time one where we are having the stream uh, flowing in a normal conditions with the classical stream profile. But if you result into the changes, okay, what will happen? So, there will be a period of non-deposition here in this area, and there will be waterlog, what we call the formation of the basin. Or we can say the formation of lake, and this is because of this damming. So, it shows here the old base level and then the present change in the base level here. Okay. So, the new base level is this one here. So, accordingly you will see the changes in the upstream side also. So slowly there will be an case because the base level has changed, and there will be a deposition which will start taking place in this area. Okay, that is your basin formation, or you can say the lake formation, and deposition will be. So then further, after this basin is filled up, okay, again it will require its profile. Okay, so eventually the original stream profile is been established, but what we see here is the extra deposited material. Okay. Deposits which was related to your change in base level. So this will be short of an alien deposits in terms of if we take the fluvial material in that region. So landscape, if you look at there are few more terms which we keep in mind when we are looking at the tectonic landforms. So Piedmont areas. A Piedmont area is an area at the base of the mountain front or the foothills. Okay, an Italian word. This is an Italian word. Ped is your foot, and monte is your hills. Okay, so this is the photograph of the Himalayan front, which shows that this portion is your. So it goes here, and then further it goes here. So there is change in the base level. So usually what we will see is that this is your base level for this particular stream. Okay, so this will be the base level for. So what you can observe here clearly is that they in this portion we have almost confined channel. Okay. And if you pass through this one, then you become short of when you are getting into an unconfined areas. So this portion is confined, this portion is your unconfined. So this is usually what we call is the Indo-Gangetic plains or the flat areas. Okay, and if I put the profile from upstream, okay, then what I see is that there is a sudden change in the gradient. So this is your what we call the Piedmont area, front of the, and there is a change in not only from the geomorphic point of view. We say there is in confined areas and unconfined within the mountainous areas, and then we are getting into the Indo-Gangetic plain or plain areas, alluvial plains. Gradient also changes. Okay, so change in gradient. And then how it is, what are the effects we see here is the change in channel pattern. We will learn about the channel patterns very soon. Okay. But I'll explain here is that these are typically what we call braided rivers. Okay. And also the landform which we see here. So this is as I was talking about, that this is your mountain front and the Piedmont area, this one here, and then it goes somewhere like this. Okay. The landform associated with this is what we call is the alluvial fan. We'll come to that part, how what are the alluvial fans and all that. So this is a typical of what we see is the alluvial fan area. These are termed as alluvial fan. So this is one of the most common landform which you will see in the fluvial system. Then fluvial landforms, as I was talking about, that these are the alluvial. If you talk about the alluvial fans, then we have will be your proximal part. This will be your proximal part, and this will be your medial part, and then finally you have the distal part. So typical of the alluvial fan, where the channel is from the confined environment, it is getting unconfined. And then other parameters, as we have discussed, we should keep in mind that there will be change in gradient and also the change in channel pattern. Another example from the Himalayan front, this is what we call Shivaliks or sub-Himalayas. So these are your Shivaliks, or we also call this in sub-Himalaya. And the contact here between the, and this side is your Indo-Gangetic plain. So this is your north and this is your south. And then contact here is in present day tectonic boundary between your Indian plate and this will be your Eurasian plate. And then fault line which we see, we will of course talk about this fault lines later also when we are talking about different environments of tectonic deformation. This is known as Himalayan frontal thrust. What is thrust and all that we will discuss later, but this is a sort of a fault what we are talking about. So what you see at the in the Piedmont area and at the contact of the Himalayan front, okay, is typical of your alluvial fans. So you have one alluvial fan, another one, so what we call the coalesced alluvial fans. And in multiple places you will see that. Okay, so this landform is very common in fluvial environment. Okay. So these are all alluvial fans in the Indo-Gangetic plain, just close to the mountain fronts. So this is one landform. Now the streams are flowing through this actually. Okay, this is again confined and then getting unconfined. You have streams flowing across along this one here. Similarly, if you see this one, and then you have very confined flow, and as soon as it comes out into the plain areas, then they are getting in unconfined. So very good example, and this is from Janauri anticline, which is in Punjab Himalaya part. And here also you can see this one is also an typical of the alluvial fan area. And similarly here you have unconfined and then getting unconfined streams over here. Now if there is, as I mentioned, that there is this one is your plate boundary and then the contact here is your Himalayan frontal thrust. So mostly what is happening is this portion is getting uplifted and that is how the Himalayas were formed because of the ongoing deformation and all that. And this will be sort of a down thrown side. So in section, if you see from north to south, and you will be able to see clearly this type of. So this is your north and this is your south, and the fault lies somewhere here, which keeps on keeps or allowing to grow this portion of the mountains. So this is the youngest mountain chain here with different landforms. Okay, so once there is a displacement here, the landforms will that sort of landforms will be seen along the frontal part. Okay, which has nothing to do with the normal erosions related to the uh, change in the base level because of the climatic fluctuations, or maybe because of the increase in velocity, or because of the increase in precipitation. Okay. There is another example of Kosi, and this is from Bihar, where you see a typical fan over here, and this is a typical landforms which we see across many along many rivers. Okay, so this is a close up of that. So migration of Kosi, people have been talking about that the fan which has been formed has been controlled by these two faults. Okay, that is the Begusarai fault, and then there is an Bhavanipur fault over here. Okay, so these are the two faults, and there is a ridge. Okay, which is intruding or subducting into the uh, below the Eurasian plate, and which has resulted in the formation of this fan. Okay, so this fan is because of the two faults. This is the concept which has been given by some people here. So this is the Bhavanipur fault, and this is your Begusarai fault. Okay, and there is a Munger Sarsa ridge which is in this area. I don't know how far this is true, but yes, there is another evidence which is important, like not related to tectonics, but this is purely related to your uh, flood events and excess sediments which is carried by the streams or the river during the floods. Okay, that is your bed load. So what has been seen, that there is a change in the or the migration of the channel. Okay, and this migration can be uh, tectonic also, and can be non-tectonic also. So that is the reason why we are looking at this example. Okay, so tectonic and non-tectonic, how we will be able to differentiate. So the reason of migration of these channels and reoccupying its own channel at various time frame, the years have been given here. Okay, so this is 1770. It flowed here, and this 1231, and so on. So this is because of the sediment bed load and the sediments which are carried during the flooding events. And in 2009 or 2008, this portion of the channel was been occupied. Okay, the Kosi flowed through this. So there is nothing to do, like the migration has nothing to do with, of Kosi is nothing to do with tectonics. But some people say that it is tectonic. I don't believe in that, but this is simply a normal fluvial process. Okay. Now coming to the deltas, of course they are been very commonly will be commonly seen close to the where the river goes and meet ocean. So there are different type of deltas we'll see in terms of the sediments and based on the shape also. So you will have the coarse grain deltas, and then bird foot delta is also like been seen, typical of the shape is like bird foot, and that will have fine grain deposits. Okay. So one of the example from the one of that is the largest delta in the world, is the Ganga Brahmaputra delta. Now there is one catch here, is that if you look at the Ganga Brahmaputra delta, it has been affected by, of course, storms and then tsunamis. This is all paleo tsunamis we will take, okay, and also by sea level change. Now there is one study which indicates clearly that if there is a rise in the sea level, and this rise in sea level and sea level rise and fall, if we take, okay, so rise and fall of the sea level will be climatic, okay, so climate change. Now this is going to take time, okay, but if of course the sea level is rising now, and if the sea level rises by at least by a meter or so, then most of this area will get inundated. But at the same time, if there is a sea level fall, okay, so rise, inundation will be there, most of the area will be getting inundated. But if there is a fall, then this will extend, okay, further down. The coastline and the processes will extend further down, and large area and the population is going to be affected by that. Okay. Now there is a similar evidence of this type of delta in Great Run of Kutch. Okay. But in Great Run of Kutch, there is no sea at present where the deltas were formed. Okay. It's completely dry. So what were the reasons for that drying up? Whether it was climate or it was just related to your tectonic activities. Okay. So we will talk about Kutch. So if you look at the, I'll just roughly put the Kutch like sketch here. So if you look at the Kutch area, then this portion, this whole portion was under the influence of the shallow sea, and the rivers which were draining this area. Okay. So this is the boundary of Kutch here. Okay. So this area is like deltaic region, okay, which is we know because based on the sediment records. Okay. So why this area uh, was dried up completely and the sea level has receded, whether it was a sea level fall or it was because of the tectonic uplift. Okay. So that part we will talk later on. Okay. So this is what it has been. The study says that Bangladesh is vulnerable to catastrophic flooding from river as well as tropical storms. And as I told, also because of the tsunamis, because this is the area which is close to the Arakan subduction zone. Okay. So 20 to 30% of the country is flooded each year. Okay. Half of the population lives at an elevation less than 8 meters. 17 million people lives at an elevation less than 1 meter from mean sea level. So if there is a sea level rise, as it has been predicted, okay, this whole area will be affected, and that is purely non-tectonic. It is nothing to do with the tectonics. It is mainly related to the climatic change, and you will have sea level rise. Okay, and as I told, that similar situation is in Kutch region. Okay, was in Kutch region, that this whole area was the deltas of major rivers, where we also talk about the Saraswati river, and this area was flourished and occupied well by the Indus Valley civilization. So what happened? Why this settlement, which is around 4,000 years old? Okay. So what happened during this phase, that is from 4,000 till present? The whole area got dried up, and there is like it is not suitable for uh, to have the ideal conditions, or okay, favorable conditions for this type of settlements. Okay, so we'll learn about this in coming lectures, that what were the reasons for this drying up. Still we are doing research, and but to up to some extent, based on some findings, will emphasize on this part also, that what happened. Okay, so we need to negate the climatic part, and then look at also the influence of the climate and tectonics, whether the climate change was so fast in last 4,000 years that resulted into the drying up of the Kutch region, which used to be uh, a flourishing site for the area for the Indus Valley civilization. So with this, we'll stop here and discuss in next lecture. Thank you so much. Namaskar.